Hello, fifth graders. Today we're going to start talking more about the planets and learning a little bit more about the planets. Now, last time we really looked at the distances, right? We were trying to make a model of the Earth and the Moon, and we discovered that there's a lot of space between the Earth and the Moon. And then we went out and saw the space in between the planets. So I have this wonderful little model, and it's awesome in terms of the order of the planets and the size of the planets, but it is really nowhere close to what the distance between the planets really is. But let's take a look just at the solar system in general. So we've got the sun, which is Sol, right? The Sol means sun in Spanish. And the first planet is Mercury. Mercury is a terrestrial planet. It's rocky. The second planet is Venus. Now, Venus is sometimes called, well, it's always called Earth's sister planet because it's almost the same size as Earth, but it is vastly different from Earth. It is the hottest planet in the solar system, which is funny, right? Because you would think that maybe it would be Mercury because Mercury is closer, but it's not Mercury because Mercury has no atmosphere. It's very hot on one side and very cold on the other. Venus, on the other hand, has an enormously hot atmosphere. It's very thick and it keeps the heat in. It's 900 degrees Fahrenheit on Venus. Then there's Earth, our lovely planet, my favorite planet. And Earth is the third planet from the sun. And then finally, Mars. And Mars is it's also a rocky planet. So we have these four rocky planets: Mercury, Venus, Earth, and Mars. They're all rocky terrestrial planets, okay? And they're all fairly close to the sun. Now there's a space in between Mars and Jupiter. And in that space, it's not empty, it's a huge mess. It's called the asteroid belt. And it is full of all kinds of asteroids and space rocks in that area. After the asteroid belt, then comes Jupiter, which is very big. It's the largest planet in the solar system. Saturn, which is so beautiful because of all of the rings. Uranus, which is after Saturn, and finally Neptune. You notice that I don't have Pluto. Pluto is no longer considered a planet. It is a dwarf planet. So these are the orders. These inner planets here are rocky. These planets out here are gaseous. They are called Jovian or gas giants, and they do not have a solid surface. If you could fly in a rocket ship to Jupiter and you landed there, you would go bloop, 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 because there's nothing to stand on. It is a gas giant. So the question I have about this solar system, remember, a system is a bunch of parts that work together. So this is a system. This solar system is like, what keeps it all together? Why aren't these planets all just flying off into space? And the reason is gravity. Gravity is a pulling force. It's pulling us down to the center of the Earth, but it is also pulling all of the planets in our solar system towards the sun. The sun is so massive, it's so big, it has an enormous amount of gravity. And that gravity is pulling the planets to the sun. But if it's only gravity, then all these planets should be pulled straight into the sun and be burned up. There's some other thing happening so that the planets orbit without being pulled into the sun. That other thing that's happening is called inertia. Inertia. And I think if you've ever seen the Bill Nye videos, it says inertia is a property of matter. And it's true. Inertia means things like to stay still. A body at rest stays at rest unless acted upon by an outside force. Or things in motion stay in motion unless acted upon by an outside force. So what does that mean? All right, inertia. So what is inertia? Well, if I have a ball and it's sitting on the ground and I don't do anything, it's just going to stay there. It's going to stay at rest until I act upon it with an outside force. An outside force would be me giving the ball a push. And if I give the ball a push, then the ball will go in the direction of my push, right? So I give the ball a push, and the ball travels in a straight line. And it will continue traveling in a straight line until something stops it. Now, on Earth, we have friction, and so friction will rub against the ball and it will slow it down. But if we're in space and there's no friction, that ball will travel in a straight line forever. Now, let's say I'm here, and I decide, curly hair, and I decide to give this ball a push when it gets to me. It comes to me, I kick it this direction, and now it's changed direction. I was an outside force once again. Okay, now we're going to apply the idea of inertia and gravity to why planets orbit the sun, or why moons orbit planets. So here's the sun, and it's huge, and it has a lot of gravity. Gravity is a pulling force. And here is a planet. Let's call it Mercury. And Mercury wants to travel in a straight line. It wants to go in a straight line, just like that. That's what it wants to do because of inertia. Inertia makes things want to travel in straight lines. But the pull of gravity from the sun is so strong that as Mercury is moving, the pull of gravity makes it orbit the sun. I'm going to go outside and do an experiment that shows this. So I want to see how this ball moves when I give it a push. I want to see if it does something interesting or out of the ordinary. Okay, here goes. So that ball traveled in a straight line because of inertia. All right, so Cougars, what I'm going to do is I'm going to make a little model that shows how planets orbit the sun and also how moons orbit planets. Gravity is not that strong a force. Look, I can jump up. I was able to get away from the pull of gravity for a short amount of time. But gravity is a pretty strong force over a long distance. So what I'm going to do is I'm going to use this wiffle ball, and this wiffle ball is going to represent a planet. Let's pretend it's Earth. And I have this string, and the string is representing the pull of gravity. My hand, which is going to hold on to the string, is going to represent the sun. Now, when the Earth wants to constantly be moving in a straight line, as we just learned, but the gravitational pull from the sun changes the motion of the Earth. Let's see how that happens. Okay, so the Earth is orbiting the sun because of the gravitational pull of the sun. When I stop pulling on the string, we will see what happens to the motion of the ball. As soon as gravity stopped pulling on the planet, that planet flew out in a straight line. And that's what would happen to all of our planets if the sun was not pulling us towards the sun. So it's really those two things together, the pull of gravity and inertia, that make planets orbit the sun. Okay, can you guys please get your science notebooks out, and you're going to get this page, solar system data. And also the next page is going to be response sheet investigation 2. So make sure to put that into your notebook and also in the table of contents, okay? So going back to solar system data, make sure you put the date. And it wants you to do, number 1, record the planets and other solar system objects in order, starting with the sun. And boys and girls, you do it sideways, right? Sun, Mercury, Venus, Earth, Mars, all the way across, okay? And then make sure if it has a moon, list the moon underneath. You can't list all the moons, right? Because Jupiter has like 60 moons, Saturn has like 65 moons. It's impossible to list all of them. But you could just say, you put a check that it has a moon or not. Now, one of the things I want you to do is, you can read all of these things about these planets, but I want you to kind of just think a little bit about some of these questions. How big are the planets? Write the names of the planets. That's number 3. Keep going. How long does it take? Let's look at number 4. How long does it take for a planet to orbit the sun? So I don't want you to look it up. I want you to think to yourself, which planets would have the longest orbit and which planets would have the shortest orbit? Let's just think about it, right? If you're really close to the sun, would you have a short orbit or a long orbit? Short. So the planets that are closest to the sun will have the shortest orbits. The planets farthest away from the sun will have the longest orbits. I just want you to kind of think about that. The next one, number 6. What is the surface temperature of the planets? Write the names of the planets in order from highest to lowest surface temperature. Now, I already told you that Venus is the hottest, so you could write Venus first, but I just want you to think about which planets would be warmer than the others. Would planets that are close to the sun be warmer than planets that are farther away from the sun? Probably, right? So I want you to kind of think and use your brain about some of these questions before you look it up. I'm totally fine with you being off a little bit, but I want you to think about what you know about the sun and distances and orbits, because you guys are smart. So I want you to fill out this page, and then on the next page, there's a question. A friend at another school sends you an email. In that email, your friend tells you that they are studying solar system, like you guys, and your friend is confused about gravity. They read in a science book that gravity is a force that keeps planets in orbit around the sun. Hey, that's just what we did. But your friend thought gravity is the force that pulls things toward the center of the earth. For example, when you drop a ball, it falls down to the ground. Your friend asked this question: is it possible that both of these things could be true about gravity? Write a reply to your friend. What would you tell your friend to help him or her answer this question? I want you to answer this question in your notebook, okay? All right, see you next time, Cougars.